So a lot of you guys asked for some examples to be done on video, and instead of creating new examples, it's really important to understand the examples that we've already seen. So I went ahead and I just sort of cut and paste the examples that we had from our notes, and we're just going to redo them on here. If you need some extra, just text me on Remind and I will gladly make new ones for you. But for this one, for example 1.1a, we come to this polynomial equation and we ask ourselves, the first thing we always ask ourselves is, what is our GCF? Well, our GCF of this is going to be x, which gives us x squared plus x minus 6. Now, if you struggle with factoring, you can create your little diamond and put your b on top. Your b value in this case is +1, and then your c value on the bottom, which is -6, and find our factors of 6. That'll be 1, 6, 2, and 3. When we set up our binomial, we can see that this sign right here tells us that our symbols are going to be different, and then the next one, that plus sign right there, tells us that we are going to have our biggest number be positive. So they're going to be different, and the biggest one's going to be positive. Now we can go back over to our diamond method over here, and we can see that we need to combine one of our factors are down here, in some sort of way that gives us a 1. So if we look closely, we can see that if we combine the 2 and the 3 by subtracting, we can get to a 1. Specifically, we need the bigger number to be positive, so that's going to be plus, and that'll be a negative, and we can double check our work. -2 times 3 gives us -6, that works out, and -2 plus 3 gives us +1. So we know that we did the work correctly. But that's not our final answer, okay? Once we're done factoring, we need to set each piece equal to 0. So each piece is going to equal to 0, and then we can solve for x. And we should get the answer of x equals 0, -3, and +2. And that is our answer. So the next couple problems are really very similar with example 1.2a and b, and then the other b on the other side. These are very similar types of questions. And so I'm going to actually change the colors so that we can keep those colors or the types of problems consistent. So with our first one, again, first things first, what is our GCF? In this particular case, our GCF is 3. So take out our 3, and we should get x to the 4th minus 6, haha, funny, minus 2x squared plus 1. We can now easily see that we can just factor like normal, and maybe it's not as intuitive to you. If that's the case, that's all right, because really it's just a case of logic at this point. I can factor this and get x minus 1, x minus 1. And if I am, unsure about whether or not I should use x, considering that I have an x to the 4th power now, you can just ask yourself, well, what is x times x? X times x gives us x squared. And does that match our x to the 4th? Well, no, not really. So what if we did x squared times x squared? Well, that'll give us x to the 4th, which is matching our first term again. So if you're looking at it and you're like, oh, that's not very easy, that's sort of hard to understand, just remember when you are picking your x values that if you just multiply them, it needs to be able to get to x to the 4th or whatever is particularly there at the moment. So we're done with this, and we can do one of two things. We can either keep going and say, oh, well, we have a difference of squares. That's x plus 1, x minus 1, and then that was that first one. So now we got to do the second one, which is the same thing, x plus 1, x minus 1. Or we could have taken sort of a different approach to it, and we could have said, oh, well, x squared minus 1 equals 0, and x squared minus 1 equals 0. And we could have solved each one. Add 1 on both sides, we would have gotten x squared equals 1. Take the square root, we would have gotten x equals positive and -1. And then, of course, the same exact thing would have happened on this side because they're the exact same problem, positive and -1. So whether you decide to go through the sort of red route or the blue route, doesn't really matter. As long as I see your work, I'm pretty happy. But both methods are going to get you to the same answer. So once we get here, we can set each piece equal to 0, and really I'm just going to do this 1 for each type, and as soon as I get my answer, I'm done. I don't need to set, I could set 3 to 0, but nothing really happens to that, so I can just exit that out. But this is going to give me x equals -1 and +1. But there are 2 negative ones, so I'm just going to show that there's multiplicity here, and there's 2 positive ones, multiplicity there. So my answer for this one is going to be x -1, x +1, with multiplicity of 2 on both of those. If we were sort of going the burgundy route over here again, we could have done the same thing. We could have written it again as x +1, -1, and you could have done a duplicity or multiplicity down here, and it would have been basically the same thing. But I will say that I prefer this method right here. So we can move on to the next problem, which is, again, very, very similar. We can look at our GCF and figure out it's going to be a -2 this time. It's going to be -2 because you're not really allowed to have a negative value as your first term. It's just sort of a faux pas that you're not really supposed to have. So we take out a -2, and we get x to the 4th minus 8x squared plus 16. And then we can go ahead and graph, or not graph, but factor. This will give me x squared minus 4 and x squared minus 4. Again, if you are not as strong in your factoring, you could have done your diamond method here. Put your -8 on top, your 16 on the bottom, and done the factors of 16, which would have been 1 and 16, 2 and 8, and 4 and 4. We have to ask ourselves, what can we combine to get a -8? And the answer is our -4s, or our 4s. And to be more specific, it would be -4s. All right, so whether you decide to go with blue route or with the burgundy route or red route, doesn't really matter. I'm going to do the red route this time. We have our -2 equals 0, which is nothing. X squared minus 4 equals 0. X squared minus 4 equals 0. And we can add 4 to both sides. And since it's the same equation, I'm just going to do it once. X squared equals 4. Take the square root. X is going to equal positive and -2. And again, since I have the same exact equation over here, I have the same exact answer. And so our answer for this one is going to be x equals 2 and -2, and both of them have multiplicity. So this is our answer. And I'll go back and I'll show the graph for this in a second. But for now, we can just continue on. The last equation that is following the same sort of pattern is over here with this one. And so again, factor out our GCF, which is just 4. We get 4x squared, or x squared, minus 10x squared. Oh, my apologies. This is not 4x squared. This is 4 times x to the 4th minus 10x squared plus 9. All right, so we can set up our x. Our b value goes on top, which is -10. Our c value goes on the bottom, which is 9. Factors of 9 are 1 and 9, and 3 and 3. The combination that gets us to -10 is going to be a -1 and a -9. So we can go ahead and factor this out. X squared minus 1, x squared minus 9. All right, I'm going to follow the red route this time and set each portion equal to 0 and solve. And since they're different, I have to do it both times. So this one will give me x squared equals 1. Take the square root. X is going to equal, I'll put it over here, positive and -1. And then we do the same thing again for our x squared minus 9, set it equal to 0, add 9 to both sides, and we should get x squared equals positive 9, take the square root, and we should get positive and -3. So this one actually has 4 answers, and you can write it out like this, or you can write them out separately. I don't really care. I think that this is more clear personally, but I understand this as well. So, All right, the next one is also the same sort of idea, but now we're changing it and we're just applying a different method. And the different method that we're applying this time is our factoring by grouping. So factoring by grouping only occurs when you have 4 terms. We have our 4 terms, and so step number 1 is to group them into pairs, which I've just done. Step number 2 is to find the GCF of each pair. So the GCF of the first pair is going to be negative x squared. And again, it's a negative x squared because I need to get rid of that negative in the first term. I don't like, or math doesn't like it when you keep the first term as negative. So this is going to give me an x plus 1. And then I do the same thing with my next one. My GCF of the next pair is 9, which is x plus 1. Step 3, my bad. Step 3 is to take the pieces that are the same, which is this and this, and bring them together. After that, you're going to take the pieces that were not used, so that's going to be your negative x squared plus 9, and put those together. Once again, we have a negative over here, which is just no bueno. So we're going to take that out, and we'll get negative 1 x squared minus 9 x plus 1. And from here, we can set each piece to equal to 0. I can set that negative 1 to 0, which doesn't work out. X squared minus 9 equals 0. Add a 9 to both sides. And we should get x squared equals 9, which is going to be x is positive or negative 3. Do the same thing for our x plus 1. Thankfully, it's not x squared, so it's just going to be one answer here, and it's going to be a negative 1. So in this one, I have an answer of positive and negative 3, and then a negative 1. Our last one is going to be similar to our blue, but before we do that, we actually have to bring over our we have to make sure it equals 0, and this is preventing us from equaling it to 0. So I'm going to subtract that on both sides, and I have to subtract it because I have to use the inverse operation. So when I do that, I should get 2x to the 5th minus 14x cubed plus 24x. And the reason why our x cubed goes in the middle is because we have to make sure it's in standard form. Standard form, again, is when you are going from the biggest exponent to the smallest exponent. After that, factor out your GCF. That'll be 2x, which gives you x squared minus 7. Oh, no, not x squared. I keep wanting to put x squared because that's just what's normal. It's actually x to the 4th, because we had 5, take away 1, minus x squared, and then a plus 12. We can do our x. Negative 7 goes on top, 12 goes on the bottom. We got 1 and 12. We got 2 and 6, 3 and 4, and I think that's it. The combination that gets us to 7 is going to be 3 and 4, specifically negative 3 and negative 4. So it'll be 2x, x squared minus 3, x squared minus 4. So again, each piece needs to go to our 0, so it'd be 2x equals 0, which actually, this time it does work out. It's going to be 0 this time. X squared minus 3 equals 0. Subtract 3 on both, or excuse me, add 3 on both sides, and we get x squared equals 3. Takes the square root, and we can't actually do anything with the square root of 3, so it's just going to be positive and negative square root of 3. And then our x squared minus 4. We are adding 4 on both sides. We are taking the square root, and we should get positive and negative 2. So this one's actually going to have 5 answers, and that makes sense because our exponent right here is 5, and so therefore we should have 5 answers. So that makes sense, and it all works out. Well, I know this video was long, but I hope it helps you whenever you're doing your homework tonight. If you have any questions, please text me on Remind, and have a good night.